Welcome to Ask and Learn.
Okay, sorry everyone, the screen's a little bit messy today, but we can work through it. So let's start by balancing this equation on the top. So I like to start with numbers, coefficients, I suppose, that we know only can go to one thing. So that's a little confusing, but for instance, this is the only C on this side, so we shouldn't start with the O's because we have an O from CO2 and we have an O from H2O. So manipulating either one, it'll probably be difficult. So I like to start with C in this case. So we know that there's 6 C's over there. So let's add a 6 here. And I suggest balancing with a pencil just so you can erase, because a lot of times I'll try a number and then erase it. Anyways, so that gives us 6 C's on this side and 12 O's. So we have 12 H's over here. So we've balanced the C's. And we have 6 O's there and 2 O's there. So we have 8 O's there. So most likely, when you see an O2 kind of on its own like this, this will be a great thing to balance last because you can add the extra O2s. So next, let's do the hydrogens. So we know we have to have 12 hydrogens on this side, so we'll add a 6 there. And then that will give us 6 more oxygens. So in total on this side, we have 12 oxygens plus 6 oxygens, so 18 in total. And on the other side, we have 6 and then 2. So we need this O2 to give us 12 oxygens in order to balance, because if we have 12 there, then we'll have 18 in total. So by adding a 6, that is balanced. All right, now let's start with, kind of going to jump around here, but let's find the delta G of reaction, and then we can go on to find 1 gram, the delta G of reaction for 1 gram of glucose. So again, we're going to use delta G of reaction equals products minus reactants. Always remember to fill in your coefficients. So we have a times 6 there and a times 6 there. This should be a plus sign. I don't know what happened there. And then this is times 6. All right, so now you're just going to plug and chug through the numbers. So the CO2 we have, these are all in kilojoules. I'm not going to write kilojoules just for the sake of time, but 394.4. This is negative 237.19. And then we have O2 is 0, and C6H12O6, glucose, is negative 910.56. All right, so if you want to pause the video and do those calculations, remember to multiply each of these by 6 because of the coefficient, and you should come out with a delta G of reaction of 2,878.99. Great. All right. So then the final step is asking for the delta G of reaction of 1 gram of glucose. So I'm just going to use a big G here to represent glucose. We know 1 gram of glucose. Let's first get this into moles, because if we can get this into moles, we know that this is the delta G for 1 mole of glucose. So if we can find out how many moles of glucose there are in 1 gram of glucose, we can use this as a conversion factor. So 1 gram of glucose times 1 mole of glucose is 180.16, excuse me, 180.16 grams. Now, in order to cancel the moles out, so we've canceled the grams here, we can say that negative 200, oh, I'm sorry, I misspoke. Oh my gosh, I misspoke. All right, this is actually no negative, 200 or 2,878.99 kilojoules per mole of glucose. So if you multiply out there, sorry, this is getting very messy, but you should get negative 16 kilojoules per 1 gram of glucose. Okay. I'm going to start using a different color so we don't get these problems mixed up. Okay, moving on to the next one. So again, let's find something we can balance that is only in one of these. So it looks like H is a good bet because we have C here and C here, and we have O here and O here. But this is the only molecule on this side that has an H. So we know that we have to get 12 H's. So because we have 12 H's on this side, we should get 12 H's on this side. So always make sure you also recognize that there's 5 H's here and 1 H here. So that's 6 in total in this molecule. So in order to get 12, we're going to multiply it by 2, and that'll give us 12. And then from there, let's see how many carbons we have. So we then have 4 carbons in this molecule and 2 oxygens. So we know that we need to get 6 oxygens in total and 6 carbons in total. So that means that this must be 2 CO2s, because this will give us 2 carbons from that and 4 oxygens. And then all in all, we will have 6 oxygens on this side, 12 hydrogens, and 6 carbons. So that is balanced. All right, and then we're going to do the same exact thing. Our delta G of reaction equals products minus reactants. Again, let's plug in our coefficients. So we have a 2 here, and we have a 2 here. There's not a lot of room, so I'm just going to put it down below. Okay, and then we know the delta G's of these are, and again, the delta G's are standard, so you should be able to look them up online, but I'll just give them to you now for a little ease. But 394.4, and then C2H5OH is negative 174.8, and glucose is negative 910.56. Again, so you're just going to plug and chug through that. If you want to pause the video and calculate that, your delta G should come out to be negative 227.84 kilojoules. All right, and since we're doing it in grams, again, it's asking for 1 gram of glucose. We're going to do the same exact thing. So I'm going to leave out the units just to make things go a little faster, but we have, you know what, I'll just make sure no one gets lost along the way, I'll do the units. 1 gram of glucose gives you 1 mole of glucose for every 180.16 grams of glucose. And just a quick note, the way I got this number is the molar mass of glucose, if anyone is confused on that. So I'll just put MM. And then we'll use our conversion factor. Sorry about that. We'll use our conversion factor, negative 227.84 2.4 kilojoules per mole. And if you multiply those out, you should get a value of negative 1.26 kilojoules per 1 gram. Great. All right, let's move on to this last one. I'll use red for this last one. Okay, again, let's start with something that we know we only have to balance for one of the molecules. So we could start with carbon or hydrogen. Let's start with hydrogen. So we know that we have 6 hydrogens on this side. We have 1 O, and we have 2 C2s, and then we have another O2 right here. Again, it's best to save these types of O2s for the end, because you know you can always add a coefficient to make sure that everything adds up correctly. It makes more sense in practice. But okay, so we need to get 6 H's on this side, so we're going to add a 3 here. So that gives us 6 H's and 3 O's. And then we know we have to get 2 C's, so let's add a 2 here and see if we balanced this correctly. So that'll give us 2 C's and another 4 O's. So we have 7 O's in total on this side, but we only have 1 O here. Well, that's okay, because we can get another 6 O's from this if we put a coefficient of 3 right here. All right, so this is all balanced out. And again, for the last time, we are going to use our delta G equals products minus reactants. So H2O, I'll give you these values again. The standard G of H2O is negative 237.19. CO2 is negative 394.4. C2H5OH is negative 174.8, and O2 is 0. Again, you're just going to plug and chug through that. Oh, you know what? I forgot one thing. You always want to add the coefficients. So we're going to make sure we add the coefficients from our balanced chemical equation there. We have a 2 here. This would just be a 1, so we don't need to put it. And then we have a 3 here. All right, now you can go ahead and plug and chug through that, and you should get a delta G of reaction of negative 1,325.6 kilojoules.